Today I will be giving you an overview of synthetic division. Now, synthetic division is often used because it's simpler and easier when dividing polynomials by a linear factor. In this case, we will use it to find the zeros of the function f of x equals 2x to the third minus x squared minus 9x plus 9. Finding zeros simply means finding the places on the x-axis where the graph of the function touches. Keep in mind zeros can be real or imaginary. If there is a case where you have imaginary zeros, they come in pairs. You can never have an odd number of imaginary zeros. Also, the degree of the leading term, in this case 3, equals the total number of zeros in the function that we can have. So, when we begin to first look at this problem, we have to use something we call the rational zeros theorem. And when we use the rational zeros theorem, we take the last term, which should be our constant, which is 9, and then the coefficient of the first term, which is 2. We put the 9 up above, the 2 below, and we find the factors of each. The factors of 9 are 1, 3, and 9. The factors of 2 are 1 and 2. But it's not just that, it's both the positive and the negative aspects of it. So it's plus or minus 1 on the top, plus or minus 3, plus or minus 9, plus or minus 1 on the bottom, and plus or minus 2. So now we can actually get into the synthetic division process. When we start with the synthetic division, we draw our line here, we create a little box. This will be for the number we first used, and then we list our terms in order. We do not include the variables, we just list the numbers and any sign that they may have in front of them. So 2, negative 1, because negative x is technically negative 1x. Minus 9 plus 9, which is just simply 9. Now, at this point, with the rational zeros theorem, you would be able to put all of these over each other, so you would know that you would have 1 as a possibility, negative 1, 3, negative 3, 9, negative 9, 3 over 2, negative 3 over 2, 9 over 2, and negative 9 over 2. So these options would all work possibly to find the zeros. Now we know we can only have 3 zeros. So if there's any imaginary in this case, there would only be one set of imaginary, which means only one of these would work in this situation. Now, you would go through until you found one of these that worked. Now, sometimes what I do is I put in my graphing calculator, and when you do that, you can find the spot where it crosses. I happen to know that one of them is 3 halves. So I put that in there. Then you have the 2, you bring the 2 down. What's 3 halves of 2 is 3. Negative 1 and 3 is 2. 3 halves of 2 is 3. Negative 9 and 3 is negative 6. 3 halves of negative 6 is negative 9. 9 and negative 9 equals 0. We know 3 halves is a 0 for this function because it comes out with a remainder of 0. If it had a remainder of a real number, then it would not be a 0 because it does not come out evenly. Now, in theory, you could go ahead and check all these to make sure they did work first. But now that it's a quadratic, we can assume that there's imaginary zeros. So this actually is 2x squared plus 2x minus 6. And what we'll use is a quadratic formula to find the remaining zeros. So x equals negative b plus or minus the square root of b squared minus 4ac. That is all over 2a. X equals, so in this case our b is 2, so negative 2 plus or minus the square root of 2 squared minus 4 times 2 times negative 6. And again, that's all over 2 times our a value, which in this case is 2. So we'll go ahead and simplify this. So x equals negative 2 plus or minus the square root of 4 plus 48. Because negative 6 times 2 is negative 12. Negative 12 times negative 4 is 48. All over 4. So now I can simplify this a little more. X equals negative 2 plus or minus the square root of 52 over 4. Now 52, we don't want to leave that as a radical in that form because we can make it better. So I like to do this thing we call upside down division. So we take the 52 we draw this almost an upside down division bar, and we want to find the lowest prime number that goes into this. In this case, it's 2. So 52 divided by 2 is 26. 26 divided by 2 is 13. Now 13 is a prime number, so we will not go any farther with that because nothing else would work. So we see that we have these two on the outside. Since we have a pair of the same number on the outside, they will stay on the outside. But the 13 will go back onto the radical. So it will look something like negative 2 plus or minus 2 radical 13 over 4. Now x equals negative 2 divided by 4 is negative 1/2 plus or minus 1/2 of radical 13. We can make that a little bit simpler. We can go x equals negative 1/2 plus or minus square root of 13 over 2. That's not a necessary step. It just cleans it up a little bit. Now, for our zeros of the function, we have this 3/2 from up here, negative 1/2 plus radical 13 over 2, and negative 1/2 minus radical 13 over 2. Those are our 3 zeros. We have 3 zeros, which matches up there, and therefore we have solved this equation.